Okay, in this chapter, we've been looking at how to combine functions and mainly through the operations of addition, subtraction, finding the product, and also finding the quotient. We've also discussed the domains of those resulting combinations. And now we're going to take a look at another way to combine functions, and that's called compositions. There are different ways that you will be prompted, different symbols, in other words, that will be used that are going to indicate that you are to do a composition. This is one of the ways that is very typically used in books. This is F circle G. Notice that it is different from a multiplication symbol, being that it's an open circle. So when you're being asked to do a composition, this is read F composed of G. It can also be written this way, where they have it in a double parenthesis type style. And this is also read F composed of G. A composition, you're combining two functions through substitution. You're going to be substituting the inner function into the outer function, whether it is written in this form or whether it's written in this form. So just exposing you to the two different styles in which they will prompt you to perform a composition and how you verbally describe what you're doing. On the other hand, if you see G on the outside as the outer function, this would be read G composed of F. And it can be written this way with the open circle, or it can be written like this with the double parentheses. Up above, I have described both of the functions for you. This is the f of x function, linear, and this quadratic function represents g of x. When you're asked to do a problem like this means that you're doing a composition and then evaluating it at a certain number. So if you've already done that composition, which we will have in part B, we can just take the answer that we get here and substitute in the 2. Okay, now let's go into actually performing these compositions and just see what the maneuvers are for getting this done. Mainly, you're just going to be going through some algebraic operations that you should be pretty good at by now. How to FOIL things, how to substitute one in for another, how to combine like terms, all the regular operations that you've been doing throughout the entire chapter. So let's do part A first. And I think the best way to look at this is that whenever you're doing a composition, again, there is an outer and an inner function, and you're always going to open the outer function. You will always perform the composition in that manner. And when I say open the function, I just mean take the function that's on the outside, which is the f function, copy that function, the right side, not this is just the name of the function, copy that function rule, but leave a parenthesis wherever there's an x. So in this case, it would be 3 times x minus 4. Okay, and that's what I mean by opening it up. And in this way, you prepare a spot where you can substitute. You're going to be substituting the g function into the f function. The g function, as you can see up above, is x squared minus 2x plus 6. So you're going to put that function, that g function, copied the wrong sign, into that open spot. Okay, then you're going to distribute that 3 to every single term in the parenthesis, as you always have. So just operations that you've been doing all along. We're distributing right now. Drop down that minus 4, and then of course always give your answer in as simplified a form as you possibly can. So this would be 3x squared minus 6x plus 14, and that represents f composed of g. And the reason that there's a little x here is because this is f composed of g in terms of x. It is written using only the x variable, and that's why there's a little subscript of x, just so you understand the symbols that are being used there. So that's part A. Okay, part B, we're going to go back the other way, and we're going to do g composed of f in terms of x. So our final answer will have just x's in it. Okay, as I stated when I did f composed of g, you're always opening up the outer function. In other words, writing the g function, but using parentheses wherever there's an x. So that g function, that was this one right here, the x squared minus 2x plus 6, x squared minus 2x plus 6. And then inside of that open spot, you're going to plug the f function into the open spots in the g function. So the f function, let's look up here again. It was 3x minus 4. And that is what we're going to be plugging in here. Okay, one of the common operations that you are using quite often is foiling. You know that 3x minus 4 squared can be written like this, although there is a shortcut for it. You can leave it just like this if you'd like, and you can do square, double, square. When you do two, and I'll do it the long way as well, that means you writing it out as itself, as expression times itself. And then, of course, this is part of it. But as far as this shortcut that I'm reminding you of right now, you could just leave it like that. That's why it's called a shortcut. You don't have to write it out twice, and you don't need the foiling arrows. You would square, getting 9x squared. You would multiply this times this and get negative 12x. Negative 4 times 3 would be negative 12x, but then double it and get negative 24x, and then you would square that back term to get positive 16. So that's doing it without writing it out like this or without using foiling arrows. If you prefer to write it out like this, do so, and then it would be 3x times 3x. That's where the 9x squared comes from. You would get minus 12x and then minus 12x again, and then positive 16. It's just that you would get it through 4 successive steps. And you'd have to also combine like terms as your 5th step. Here you just get it in 3 steps. So 9x squared, that's that. Then this middle term comes from this arrow right here, this long arrow, negative 12x, and then another negative 12x right in there, which is where that middle term comes from, and then positive 16 from there. Then distributing this 2, at the same time you distribute the negative, so it's negative 2 times 3x is negative 6x. Negative 2 times negative 4 is positive 8, and bring down that 6. So you see that this is significantly more work than part A, only because you are squaring a binomial. That's why I think you should use the shortcuts when possible, so you might want to memorize those shortcuts for foiling. Okay, combining like terms so that you can give the simplest form of this answer would be 9x squared. And then as far as your x terms, you have negative 24x and then another negative 6x. Combined would be negative 30x. And then as far as your constants, you have 16 and 8. That would be 24. And then 24 and 6 would be 30. And that represents G composed of F in terms of X. Okay, in part C, you've been asked to take G composed of F and evaluate it at 2. So we already have the G composed of F function. So all we need to do in this part is just plug 2 in. Okay, so everywhere that there was an x in this answer right here, 9x squared minus 30x plus 30, I put in the 2. Okay, so this is going to be 9 times 4, which is 36, minus 60 plus 30. And you can put that in your calculator, but that's going to be, let's see, this would be These two together would be negative 30. Negative 30 plus 36 would be 6. So G, and you can just put all three of them in your calculator if you prefer to do it that way. So G composed of F and evaluated at 2 is equal to 6. And that is it for three examples of composition.